Hi, I'm Priya Shetty, a product manager with Azure Storage. Welcome to today's session on No Data Silos with Azure Blob Storage. Before we get started, I'd like to walk through how we will spend the next 30 minutes or so. We'll take a look at how data-driven today's digital economy has become. We'll explore some of the data architecture paradigms in the cloud, how to empower this data-driven economy with blob and data lake storage, see some of the key use cases that storage supports, and how multi-protocol access helps ensures that there are no data silos. We'll take a look at the partner ecosystem that storage integrates with and discover what's new in blob and data lake storage. We'll take a look at some of these capabilities in action, and then we'll finally wrap up with some real-world customer scenarios on how they have implemented data-driven solutions on our platform. When you think about today's digital economy, it's becoming more and more data-driven by the day. When you think about the data in the cloud, we are forecasted to exceed well over 100 zettabytes by the year 2025 alone, just in the cloud. This data could be data coming in from devices and sensors. It could be data coming in from satellites, from cloud systems, from data warehouses and databases, or multiple formats like structured data, unstructured and semi-structured data, media, and log files. So along with this volume and variability and velocity, we are seeing a lot of variety of data which are getting ingested into this cloud. We also see a number of ingestion patterns in addition to that. You could be seeing batch processing or micro batch processing or streaming in near real time. Some of the use cases require that as the data is getting ingested into the cloud, you need to send it down further to real-time apps so that you can get quick insights to react for your business. Other use cases demand that you prepare and train your data and model it for advanced analysis. That data is sent further down to various AI and ML platforms and data science platforms. In addition, you may also want to generate reports and dashboards to understand the health of your business. When you look at this end-to-end view, gaining value from data is at the heart of everything that we do, and data is the product. Let's take a look at some of the data architecture paradigms in the cloud. We'll start with the data warehouse. That takes a top-down approach to data. It's very well suited for structured data because the focus is on upfront transformation, so it's schema on write. And there is a higher cost of ownership because of this upfront transformation as well. Another paradigm is the data lake, which takes a bottoms-up approach. The idea is to get in the data as quickly as possible so that you can expedite access to the data to your downstream users and applications. So it's schema on read. It's extremely well suited for semi-structured and unstructured kind of data. The idea here is to explore the data in order to identify the value. Now, these two paradigms have been around for many years. They are very well established and mature. But we are starting to see some newer paradigms gain traction in the cloud. One that comes to mind is the data lakehouse. It takes a hybrid approach. You have the data warehouse, the data lake, and a layer of governance joining the two. This is very well suited for different kinds of data formats, and all of this is converted to Delta Lake, which enables asset transactions and time travel. These three paradigms are based on a centralized ownership model. But when you think about a newer paradigm that's gaining traction, data mesh, that is focused on a decentralized ownership model. Instead of having dedicated IT or business user teams, the focus is to build cross-functional domain data teams. And data is the central product here. So the focus is to build an ecosystem of data products to which you can subscribe and then use that for your insights and processing needs. Regardless of the data architecture paradigm you look at, the variety in the data architectures, in technologies, the variety of data formats, ingestion and processing patterns clearly demand that your platform needs to be very, very flexible to handle these variations. And it needs to be scalable, performant, and secure at the same time. Now we are going to learn how to empower this data-driven digital economy with Blob and Data Lake Storage. Blob and Data Lake Storage is extremely scalable and durable. We have a global footprint and we have exabytes of data that are stored and processed today. We also have a number of redundancy and failover options that help you recover from zonal or regional failures. That helps ensure business continuity. In addition, it is very secure and compliant. It gives different options like policy, AAD, coarse-grained, RBAC, fine-grained ACLs, and a number of networking options as well, for example with VNet or firewalls or endpoints. In addition, it is extremely cost-effective. The costs have come down to $1 per terabyte, and you can leverage capabilities like lifecycle management. Based on the last access time, it will tier the objects from a hot tier to a cool tier and further lower your cost of ownership. In addition, it also has comprehensive data management capabilities by which you can apply policies on billions of objects on your storage platform. And it has foundational optimizations that are built into the platform that are extremely supportive for different kinds of demanding workload types. Let's take a look at the key use cases that Blob and Data Lake Storage support. We'll start with machine learning and AI. Think about ingesting large amounts of data in different formats and then using that data, both historical and current, to prep and train your models. With this, you can gain rich insights to drive your business and also understand are there any anomalies or outliers or patterns that are difficult to detect manually. This helps with different kinds of use cases like drug discovery or patient care, healthcare assessment, or image recognition. Similarly, it supports another category of use cases, which is the analytics one. This could be simple reports, visualizations, dashboards, or more advanced analytics such as streaming real-time analytics, predictive analytics, and emotional analytics. All of this helps drive your business. We also support high-performance compute kind of use cases, especially with the inclusion of the NFS v3 protocol. With this, basically it helps with high-scale, high-throughput, read-heavy kind of workloads. Think about genomic sequencing or risk simulations. We also support BCDR use cases. With the help of the redundancy and failover capabilities, you can ensure that any impact because of outages can be minimized and business continuity is assured. We also offer a rich development experience and support for cloud-native apps, which helps you ensure that you can have fast and seamless development. You can spin up an application and then access and process your data at scale in the cloud. Now let's take a look at how we can enable all of these key use cases with these different protocols on a single storage platform. We have the Blob API that helps you with server backup, archive kind of data, and semi-structured and structured data coming into the platform. We have the ADLS API that helps you with analytics kind of use cases. There are very specific optimizations that are built into the platform like hierarchical namespace, HDFS compatible APIs which allow for true file folder kind of operations, and they are extremely fast and atomic. We also have the NFS v3 protocol that supports you with your HPC kind of use cases, which are the large sequential read-heavy workloads. We have now announced SFTP as well in public preview that helps you with use cases such as ingesting large data sets, which could be legacy data sets. It could be data being transferred from mainframes or ingesting large amounts of telemetry and IoT data. All of these four protocols are completely interoperable with each other. You can write with one, read from another, and this is your protocol of choice among any of these four to handle your enterprise data needs. Let's also take a look at the partner ecosystem that storage helps integrate with. We'll integrate with a number of leading platforms and solutions in the world. This could be in the area of primary and secondary storage, analytics, backup, archive and DR, data management, and container management. This further ensures that there are no data silos for your enterprise data needs. Let's discover what's new in Blob and Data Lake storage. We talked about SFTP. So SFTP is natively available in the platform as a service. You can upload and manage your files through SSH. And it uses the concept of a lightweight identity. You can configure local users and manage container level access. The best part is you don't need to provision any VMs or infrastructure for this. The second one is in-place data share. With this, you can share data from a provider to consumer storage account without any data duplication. You can have near real-time access to any shared data changes, and you can share data within the same AAD tenant or across different AAD tenants. So you can share data within the organization and across organizations. The best part is the provider only has to pay for storage that the provider incurs as well as the data access that they incur, but the consumer is billed directly for data access based on their actual usage. The next capability that we launched in public preview is cross-tenant customer managed key. So you can provision a customer managed key from a key vault in an AAD tenant that is different than the storage account with storage account's AAD tenant. This is great for ISV kind of scenarios. So you can extend the CMK capabilities to your customers. So customers can basically spin up an AAD tenant key, which is their own, and then control the data in the ISV tenant storage account. In addition to this, we have about 5,000 accounts per subscription that we have included, and there is a 20 times increase from your earlier limit. So we basically started with 250 accounts, and now you can have another 5,000 accounts in your subscriptions. So 250 accounts can be configured to standard endpoints, and 5,000 accounts can be configured to the Azure DNS Zone endpoint. In addition to this, we have also launched Storage Mover, which is an end-to-end fully managed experience in public preview. Here is the end-to-end vision for this offering, and certain components have been launched into public preview. So you start with discovering which sources do you want to migrate, and then scan through them to understand what's in that source and how is that data used. You then plan your migration by mapping your source to targets, and then plan the deployment as well, where you auto-provision target cloud storage. You then execute the migration by moving the data for both initial and incremental copies, and then minimize the downtime as well. And you can execute a number of post-migration steps to ensure that your migration has been successful. Let's take a look at some of these capabilities in action. So in this demo, we will upload data into Data Lake storage via SFTP. We will access storage via portal, which uses Blob and DFS APIs. We will transform that storage data via Databricks, Spark, and then store those results back into storage via DFS. We will share the process data as well as a subset of the original data in place to a consumer storage account. So in this demo, in this provider storage account, I have a local user already configured, and that's my landing area for the SFTP files. Let's go take a look at it. So when you navigate to Ignite Container and Ignite dir, you'll see that this is empty. I have a local folder where I have about 102 files, and we'll upload this via SFTP into storage. So I go into the PowerShell window, I connect to the storage account via that local user, and then execute the put command. So this kicks off the upload of the files via SFTP into storage. When I list the container and the directory, in this home landing area, I can now list out all of the files that have been uploaded via SFTP. So I'm listing this on portal, which is using Blob and DFS APIs. So this is multi-protocol access in action for you. Now let's take a look at the file on which we will run the Databricks job. So this is a file that contains some customer data. Let's go over to Databricks. The first step here is to attach the Databricks instance to the storage account. So it gets connected to ADLS provider. Next step is to read the customer master JSON file so that you can load it into the data frame. So all of the customer data gets loaded into the data frame with this command. Next step will be to anonymize some of these results. So I'll remove the first name, last name, and some confidential information and execute this command to just filter out some key results that I want to share with the consumer. So it just has gender information, subscription information, location, and song choices. The last step is to write out these processed results back into a JSON file, customer process JSON, into the storage account. Now that this Spark job has executed successfully, when you go back to the storage account and list out the landing path, you can see the customer master processed data that Databricks wrote out via DFS back into the storage account. And if you look at the file that Databricks wrote out into storage, you can see that this contains just the anonymized filtered out results that Databricks had processed. Next step is to share this with a consumer. I have a Purview account that I have already set up as a provider. Let's go to the Data Share tab. First step is to create a share. Let's call it Ignite Share. I click on Continue. Next step is to add assets. So I'll pick assets from my ADLS Gen 2 account, ADLS CE provider. Then I click on Continue. And I navigate to the path where I had been uploading the SFTP files. So I can pick up the processed results from Databricks and a subset of the original data that I had loaded via SFTP. I add it to the share. And the last step is to pick a recipient for this share. Once that is done, I just create the share. So in very few steps, I'm able to create a share and send an invitation to a consumer. The consumer will have their own Purview account, but for ease in this demo, I'll show you in the same account. So we go to the Received Shares tab, and if you want to see the provider share invitation, you basically need to go to the Pending tab here. There's my Ignite Share invitation. First step as a consumer is to accept and configure this share invitation. Once that is successfully done, I map it to a target storage account in my own subscription. So I have one set up, ADLS CE consumer. If you see there is nothing in here, no containers and all that are set up. Let's go back, pick this consumer storage account and provide a path to which this share can be mapped. So we put in C container 2, C folder 2 and map it to target. This kicks off the setting up of the data share policy between ADLS CE provider and ADLS CE consumer for the in-place share. Once this is mapped, you basically need to go to the Assets tab to monitor the mapping status. And once this is successfully mapped, you don't have to go anywhere. You basically, all you need to do is go to the target link that is present here to access your shared data. So what this link does is, it opens up a view of the target consumer storage account through the storage portal view. We navigate to containers to see the path on which I had mapped the incoming share. So you can see C container 2, C folder 2. And once you go here, you can see all of the data that was shared with you by the provider, both the processed data from Databricks as well as the original one. So if you look at the file which had the anonymized results, as a consumer, you can read all of the anonymized results right here. In addition to viewing and accessing the files, you can also run rich analytics on this data set and gain more insights. Now that you have seen multi-protocol access and data share in action for Blob and Data Lake storage, let's take a look at the customer journeys on this platform. We'll take a look at some real-world customer scenarios of how they have achieved some data-driven solutions on our platform. We'll start with Marks and Spencer, So it's an advanced analytics use case. Marks and Spencer is on a modernization journey. So they're trying to keep pace with the increasing demand. In this solution, we ingested a large number of Parquet files from on-premise HDFS clusters into ADLS Gen 2, transformed it via Databricks, and ran visualizations and dashboards using Azure Synapse. What this helped them with is, basically it expedited the customer analytics to influence the product design and positioning and help them be more competitive. The next journey is with Smiths. So Smiths is into industrial automation, and this is an analytics use case. We eliminated the manual data extraction from multiple business data repositories across 800 applications. All of this was consolidated via ADF pipelines into ADLS Gen 2, transformed via Databricks, and visualized via Power BI. So it eliminated the data silos across multiple applications and removed the error-prone manual data extraction process. And more importantly, it eased and made it much easier for the users to get access to comprehensive data insights in real time. The third journey is one of cloud-native apps for NetInspect. So NetInspect is an early pioneer in digitizing the aerospace supply chain, and it has an enterprise quality management system that is very widely used by companies like Boeing and Raytheon, Honeywell, and Rolls-Royce. In this solution, hundreds of millions of documents were stored in blob storage as the sole data repository, and they became instantly searchable as compared to their legacy system. They were also able to leverage encryption at rest, private endpoints, and firewall to ease security. In addition to that, the support for the cloud-native apps ensured that their development experience became fast and seamless. So this not only helped make their legacy systems more scalable, but more importantly, it helped with the manufacturing orchestration across 26,000 suppliers across 60 countries and created new opportunities to take advantage of the data. Our fourth journey is one of machine learning and AI with Rockwell Automation. They focus in certain domains like oil and gas, mining, food and beverage, and automotive. So in this solution, data from multiple sources was ingested into ADLS Gen 2 via ADF, transformed and curated via Databricks, stored back into Gen 2, and then very rich ML and AI and advanced analytics workloads were run using Azure Databricks, Azure AI, and Azure Cognitive Search. This empowered their business users with a truly data-driven mindset. And in addition to lowering their total cost of ownership, it provided them with a unified platform for all their ML, AI, and analytics needs. With that, let's take a look at some of the key takeaways from this session. Azure Blob Storage and Data Lake Storage is extremely secure and cost-effective, with multiple protocols supported on a single storage platform, ensuring that there are no data silos for your enterprise. It is scalable and performant for a wide range of workload types. It could be ML and AI, it could be analytics, it could be BCDR, HPC, or cloud-native apps. In addition, it also offers integration with an extensive partner ecosystem with the world's leading platforms and solutions. So I leave you today to explore these resources in more depth so that you can learn more about Azure Blob Storage and Azure Data Lake Storage to see how these platforms can help you in your journey to become more data-driven. Thank you so much for your time.